Combustion Analysis. The mass amount of each element in a compound can often be found by decomposing the compound into its elements by reacting it with another substance. Hydrocarbons, here's a hydrocarbon, CXHY, can be combusted with oxygen, okay, that's a fire, to determine the mass amounts of carbon and hydrogen. All the carbon will be converted to CO2, and all the hydrogen will be converted to water. This device provides controlled combustion of material, burning it, and then traps the emitted water and carbon dioxide. So we have our oxygen coming in here, and this is a furnace, so it reacts with the sample, and it emits carbon dioxide, water, oxygen, and other gases. The first area here, we have a water absorber, such as magnesium perchlorate. Second one, we have a carbon dioxide absorber, such as sodium hydroxide. Then, what comes out the other side would be oxygen and other gases. Now, if our sample only contains hydrogen and carbon, then the masses of the water and CO2 emitted during combustion is sufficient to determine the empirical formula. If a third element is present, then the original mass of the sample is also needed. Here's the analysis of what happened on the previous slide. Now we could get the measurement of the carbon dioxide mass and water mass by how much the mass of those trappers increased, right? The increase would be due to carbon dioxide and water, depending on which tube you are in. The empirical formula can be determined by determining the mass of carbon in CO2 and hydrogen in water, since in this case our sample is only carbon and hydrogen. So we have 2.6 grams of carbon dioxide times 12 grams of carbon in 44 grams of CO2, and that's 0.73 grams of carbon or 0.061 moles of carbon. The water then, here's our 2.18 grams of water, that's 2 grams of water for every 18 grams of H2O. So that's going to be 0.24 grams of hydrogen equals 0.24 moles of hydrogen. We divide both of the quantities by 0.061. That's the smallest number here, 0.061, 0.24. And what do we get? We get 1 for carbon because we're dividing it by its 0.061 mole, and we get 4 for hydrogen. So the empirical formula will be CH4. And note that the mass of carbon plus hydrogen equals the sample mass of 0.97 grams. But what if a third element is present? Then the original mass of the sample will be greater than the masses of the carbon and the hydrogen in the carbon dioxide and water. That mass deficit is ascribed to the third element. In this case, the sample is presumed to consist of carbon, hydrogen, and oxygen. Here's the total mass. Here's the excess oxygen. And here's what we got for carbon dioxide and water through our combustion chamber. Using a similar analysis, we start with the carbon dioxide and water, and 2.91 grams of carbon dioxide is 0.79 grams of carbon. 1.78 grams of water is 0.20 grams of hydrogen. So we have our total mass, right, the left side there, minus the 0.79 grams of carbon, minus the 0.20 grams of hydrogen, and that means we have 0.53 grams of oxygen. Now we do the molar calculations. Here's the carbon, that's 0.066 moles of carbon, and we're going to divide that by 0.033. Why? Well, actually, we didn't show that till the bottom here. Here's the oxygen. The oxygen has the smallest molar concentration. That's 0.033 moles. So there's 1 oxygen because you divide it by 0.033. With hydrogen, you divide and you get 6 hydrogens. And here with the carbon, you get 2. So our empirical formula is C2H6O.